Hello students, and again welcome to the lesson sequence and series. If you remember, and again just want to remind you, before in lesson 1.1 and 3 we did functions and how do you generate order pairs. The order pairs we use to graph. Means if the function will be given and you are substituting x values to get y values, and then you generate order pairs. In this lesson we did part of some sequences, and today in this lesson still we will be investigating several different types of sequences. Okay, we did some before, but again we are doing some more. Before we start today's new sequence, a type of a sequence, I am going to give you one question just as a bell ringer, just to check if you guys still remember what you were doing before in a previous lesson. So I'm going to show you that question. Now pause this video for some minutes and then try to solve this question and figure out what is the answer of it. Okay, all right. Now the answer for this question is 37/4. Okay, again simple thing is n values are given, you substitute this n value over here, you will get the fifth term, and this is the that was a kind of review. All right, now the next thing that we are going to study is Fibonacci sequence. The topic is written right here. It's another type of sequence, and it's the most interesting sequence in math. I mean, especially for me, I really like this sequence, and it's connected and it has a lot of application, and this sequence can show you many different examples in our daily life and nature. Like naturally these have a really good sequence in our daily life that you can observe normally in your life. Okay, so how would you understand this Fibonacci sequence? I will explain this question in the form of explaining you Fibonacci series or Fibonacci sequence, and then I will properly write it down what is Fibonacci sequence. Okay, so to understand this example, we are going to read this step by step, and then we are going to, like, I will explain you. Excuse me. So suppose that a stem has to grow for 2 months before it is strong enough to support branches in sequence. And now the questions are getting harder. Sometimes you have to figure out like what quantities are they talking about. If you remember in the very beginning, when you have function, like let's say if you have written f of x, okay, f of x is equals to 3x plus 9. I'm just giving you an example. Now what is this situation? In this situation you have x value and y value, means you have two variables, right? Now in this question you also have two variables. How? The one variable right here is they are talking about months, and the second one they are talking about branches. If you read the whole question, you will figure out that they are talking about the variation between months and branches. Now look, let's read. At the end of the second month, it sprouts a new branch and continues to sprout one new branch each month. So two identities or two variables they are talking about is months and branches. Now I will try to sketch it so you can observe and understand what is or how Fibonacci sequence works. They are saying suppose that a stem has to grow for 2 months, right? So let's say like here is the plant, and like this is the stem of the plant, and it's growing this much in 2 months. Okay, so it's growing for 2 months. So I'm writing months here, months 2. okay? And here I will think about there are branches, so one branch, okay? At the end of the sequence, so once the sequence, oh sorry, at the end of the second month, it sprouts a new branch and continues to sprout one new branch each month, right? Now look, they're saying after 1 month it sprout one branch, right? So I will make one branch. Oops, sorry, wait a minute. So here is it, we are back. Alright, so I was just redrawing this diagram so it will be really clear for you guys. So I was saying that it's written right here that that a stem has grow for 2 months before it is strong enough to support the branches, okay? Now the next step is at the end of the second month. Now second month is right here. Now at the end of the second month, the end of the second month it sprouts a new branch. So at the end of second month, let's say like right here, sprout one more branch, okay? One more branch. Now if you have a one more branch, means it sprouts a new branch and continues to sprout one new branch each month. So every branch means you have next month. So let's say this is the third month and you have a one new branch. If you have a fourth month, when you have another branch, okay? So at this part you have, sorry, this was one, this part you have two, at this part you have three branches, and if you have next month more, then you have more branches. But let's read the next part. New branch each month. The new branches grow similarly, so they are growing similarly. How many branches will a plant have after 18 months, right? Now look, the interesting fact is when you're going to have a next month, let's say fifth month, then this branch which was already grew is going to have growing up another branch, right? So now how many branches total you have? So it's going to be 1 2 3 4 5, correct? 1 2 3 4 5, yes. And then each month they are growing up. So by following this pattern, why? Like because they're saying and continues to sprout one new branch each month. Each month they will sprout a one new branch, okay? So when, if this case is happening, then the 6 months, let me give you another example, the 6th month you will have more branches, okay? So one branch is growing up here, one branch will also grow up here, okay? So third month you will have this branch, fourth month you have this branch, new one, fifth you have this branch but also growing up over here, because once the 1 month 2 months are passed, stem, then it will grow one branch. Now in the 6th month, 6 months is right here, then at this point this branch will grow up and this branch will also grow up one more branch, and you are going to have this branch, okay? And the total of them are going to be 8. So you are having a one sequence that you're getting, which is right over here. Now, what is the sequence? This thing I was doing just to explain you. I know I'm going really slow in this explanation, but I want you to understand this idea completely without like skipping any part. Now the next is going to be, the sequence is, now if you notice this one, then the next sequence is going to be, look at this table. This table is exactly what I was explaining you. Months and then branches. Now this sequence, this one, the branches, this sequence is known as Fibonacci sequence. Now you notice before the questions I assigned you, you always found a pattern, right? Now what kind of pattern would you will figure out in this one? Now pause this video and try to figure out what is a pattern in this one. Okay, so you are going to have it. Now the pattern you are going to have it in this one is, look, first you write it down the first term as it is. A1, let's say, is 1. A2 is again 1 and 1. Okay, now the third term is the sum of previous two terms. So this one and this one, sum of the previous two term is the next term, which is 2. Now the next term, A4, is going to be the sum of these two, which is 3. That is your A4. Now the next term is sum of these two, which is 5. So A5 is 5. Okay, and now the next term is the sum of these two, which is 8. Next term is sum of these two terms, which is, sorry, I didn't write the sixth term, which is 8. And these two terms, the next term, A7, is equals to 8 plus 5, 13. So A7 is 13. Alright, so after these numbers are finding the difference between these terms, you got a sequence, and the sequence is 1 1 2 3 5 8 13. This sequence is known as Fibonacci sequence. Now Fibonacci sequence have a really beautiful pattern in itself. Now I will explain you some of them, what are those beautiful pattern, and like why Fibonacci sequence is really popular, like really interesting sequence. Alright, so to explain you some interesting number patterns in Fibonacci sequence, first I'm going to write it down again, the Fibonacci sequence, which is again that the Fibonacci sequence is the sum of two consecutive numbers. So 1 and 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 13 plus 8 is 21, 21 plus 13 is 34, 21 plus 34 is 5 and 5. Okay, and let's keep going up. Now the first interesting pattern is, let's take the square of this sequence. Now what would you get? 1 squared is, sorry, this is not a part of our question, it was just, so 1 plus 1 is 1. Oh sorry, 1 squared is 1, 2 squared is 4, 3 squared is 9, 9 and 5 squared is 25, 8 squared is 64. and then 13 squared is 169, and so on. Okay, because the rest of the squares are really big. So now look, you must be like, why it's so special. Now I'm going to show you why is this so special. Now look, if you add the first two terms of this squared sequence, 1 plus 1, you are getting 2. 1 plus 5, 1 plus 4, you are getting 5. Now 4 plus 9, you are getting 13. 25 plus 9, you are getting 34. So, and yes, the pattern continues. So you see that this is such a interesting number pattern in a Fibonacci sequence. Now let me show you another interesting number pattern in this one. Now let's suppose that you wanna look at adding the squares of the first few Fibonacci numbers. Then let's see what you get. So 1 plus 1 plus 4, you're getting 6. 1 plus 1 plus 4 plus 9, you will get 15. Now 1 plus 1 plus 4 plus 9 plus add 25, you get 40, right? And now next, if you will add one more term, then what you get, 1 plus 1 plus 4 plus 9 plus 25 and then plus 64, you are going to have 104. Now you can see that these are not Fibonacci numbers, but if you see them closely, then there is a pattern in it. What is that pattern? Now look at this. 2 times 3 equals to 6. Here 3, wait, if you write this term in this way, then what do you have? 3 times 2 equals to 6. Now what is it? These two numbers. Next one is the multiplication of 3 and 5, right? Now 3 times 5 is equals to 15. Now the multiplication of these two numbers. 5 times 8 is 40. Okay, and then the next two numbers are 18 and 13. So there is another thing. 8, again, this is not part of our question. Go back. And then it's 8 times 13 is going to be 104. So you see, we found another pattern in Fibonacci sequence. So with this pattern, you can clearly see that in this multiplication, in this 6, 15, 40 and 104, the Fibonacci numbers are buried. They are hidden in them, right? So like, who would you appreciate? It's a Fibonacci sequence that you have buried, and it has very interesting number patterns. These interesting number patterns I'm explaining you just so you get some interest in it. These patterns you don't have to memorize or something. Okay, now I would appreciate that if you will try to figure out, or if you, as a critical thinking, look at the Fibonacci sequence and try to come up with another and your own new interesting number pattern. Okay, I will also share a video with you. It's from YouTube, and that video will show you very interesting the applications which like connected to Fibonacci sequence. Like one example I can give you, the flower petals. The flower petal is an application of Fibonacci sequence because petals are like this. It goes like a circle, and they are keep growing up. I mean, like not exactly like this, but kind of like this. Or like a lot of other things, like they are, even the galaxies shows a Fibonacci sequence pattern. So when you will see that video, video can show you many different interesting natural things which refers to Fibonacci sequence. Here is a sample question that you are going to practice it now, and then you are going to check if you understand the pattern of finding the Fibonacci sequence. Okay, so pause this video and try to find out the answer for this one. Then I will show you what is the answer for this question at the end of this video. So the answer for this question is 6765.